All right, hi folks. Um, yeah, I've been out in the class a lot. Sorry, but it's what it is. Um, this is just me a video to help us get through the first part of the notes for today. Um, so it's here's your warm up. Go ahead and try this first. So like pause the video, just try out the warm up. Normally, as you know, we go for like 4 minutes on that. So just time yourself for 4 minutes and just try some of these problems. And when you're done with that first attempt, then you can unpause the video and we can go ahead and get into it. But go ahead and try this first just on your own and see how you do. All right. So hopefully now you're unpausing the video after pausing and trying some of these problems. Let's go through this real quick. So as we talked about last week, you want to follow just the order of operations on some of these compositions, just go from the inside out. And so when I think about cosine of negative 7 pi over 3, so terminal right here, negative 3 pi over 3, negative 6 pi over 3, negative 7 pi over 3. But I want to find the cosine of that value. So that would be 1/2. So really I'm trying to evaluate what is arcsine of 1/2. Right, but that would be a whole new diagram because now we're looking for a y value of 1/2 specifically in quadrants 1 and 4. So that sine value of 1/2 would be occurring at the angle measure of pi over 6. Right, so that's your answer for the green. Let's talk about the yellow. So our cosine of negative 3 pi over 7. And you may be saying, well, I don't know how to evaluate cosine of 3 pi over 7. And you know what? Fair enough. I don't know how to evaluate that either. Right, but here's the thing. You actually, as a final answer, don't need to know what the cosine value of 3 pi over 7 is. Like, really what you need for your final answer is some angle measure, right? Like the last function that we're going to be evaluating is arc cosine. So the output at the end of this whole problem is going to be some angle measure. If we can find the right angle measure that lines up with this cosine value, then I think we'll be good to go. Right, so let's go ahead and locate negative 3 pi over 7 just to start. Right, so we're going to say negative 3 pi over 7, which is less than pi over 2. In the negative direction. So negative 3 pi over 7 would be somewhere in quadrant 4. Right. And so the cosine value is some positive x value, right about here. Right. But the arc cosine value that output that angle is going to be somewhere from 0 to pi. Right. And all we're looking for is a cosine value that matches this positive x value. Right. So if I just sort of keep that x value and literally just kind of like reflect over the x-axis into the correct interval, the correct range that I'm looking for arc cosine. I think it's fair to say that 3 pi over 7 would have the same x coordinate, right? The same cosine value as negative 3 pi over 7. Right. So at the end of that, like this whole output just ends up being 3 pi over 7. Right. And that really is kind of like the two things that you want to use for these types of problems. And we'll practice this as we go on to page 2. But number 1, right? reflects into the correct quadrant. So -3 pi over 7 was in quadrant 4. That quadrant isn't relevant for our cosine. We reflected over the x-axis into quadrant 1, where we have the same cosine value, right? But now we're in a quadrant that is actually relevant to our cosine. So reflection to the correct quadrant. And 2, keep the same reference angle. Right, so both -3 pi over 7 and 3 pi over 7 have the same reference angle of 3 pi over 7, right? So while we were in quadrant 4 to begin with, and then we end up in quadrant 1 over here, right? By keeping the same reference angle, we make sure that we keep the same cosine value, right? And so now we actually get an angle measure in the correct quadrants that has the same cosine value as -3 pi over 7, right? So everything lines up. I know that's not necessarily like maybe clicking right away. We'll do more of those problems on page 2. Before we get there, I'll just do the red problem really quick. The red problem, honestly, maybe you thought the red problem was easier than the yellow. I don't know. But I'm just gonna do a little order of operations business here. Inverse cosine of -√2 over 2 would be 3 pi over 4. And inverse cosine of 1/2 would be pi over 3. So cosine, let's put that over 12. 9 pi over 12 plus 4 pi over 12 be 13 pi over 12. Split that into 3 and 10. Cosine of 3 pi over 12 being pi over 4. And 10 pi over 12 being 5 pi over 6. Use subtraction there, so cosine, sine, sine. Cosine of pi over 4 is √2 over 2. Cosine of 5 pi over 6, -√3 over 2, minus the sine, and then the sine of 5 pi over 6. So -√6 over 4 minus √2 over 4. And then we'll combine that into a single fraction. I guess that was easier than yellow. I don't know why I put it in that order. Maybe because I wanted you to try the yellow. I don't know. Anyway, let's do some more problems like the yellow, since that's probably what you want to see more of. Inverse sine of 7 pi over 5. So yeah, again, I don't know really what the sine of 7 pi over 5 is. But at the end of the day, that's not the thing that I need to deliver. I need to deliver an angle measure, right? An output of arc sine that has the same sine value as 7 pi over 5. So I'm gonna go ahead and draw a set of axes. 7 pi over 5 would be past 5 pi over 5, somewhere in quadrant 3. But inverse sine as an output in quadrant 1 or 4 from -pi over 2 to pi over 2. Right, so I would be looking for an angle measure that has the same sine value, right? The same y coordinate. So actually, I'm going to make like an actual circle here to illustrate this point. Right, so you can kind of see how those two angles have the same y coordinate, the same sine value. based on where those rays hit the unit circle. But I'm not going to use 7 pi over 5 as the final answer for this problem, because if we're evaluating inverse sine, sort of as the overall structure of what we're doing, I would need an angle, I would need an output that resides in this interval from negative pi over 2 to pi over 2. Right? So based on what we talked about up here, right? Oh, sorry, that was the wrong box. Reflecting into the correct quadrant, we did that. So we were in quadrant 3, not relevant to inverse sines. We reflected the terminal array into quadrant 4, but we want to keep the same reference angle. So 7 pi over 5 has a reference angle of 2 pi over 5. And we want to keep that here, 2 pi over 5, as a reference angle, because our angle measure will be directional. I would say final answer here, negative 2 pi over 5. Right? That would be the measure of the angle in quadrant 4, right, between 0 and negative pi over 2, with a reference angle of 2 pi over 5, negative 2 pi over 5. All right, let's do another one of those. So inverse cosine of cosine of 11 pi over 9. So setting up axes, unit circle, I'm dealing with inverse cosine. So I'm going to be looking quadrants 1 and 2 from 0 to pi. 11 pi over 9 is going to be past 9 pi over 9 or past pi. So actually, let me make that dash over here. So that would be about 11 pi over 9. So that angle is falling outside of our desired range for inverse cosines. I'm going to reflect into the correct quadrant. And I want to keep the same reference angles. So this reference angle here would be 2 pi over 9, right? 11 being 2 past 9, or 9 pi over 9. So same reference angle here, 2 pi over 9. So I think we're looking at 7 pi over 9, right? That would be the measure of the angle in quadrant 2 between pi over 2 and pi, with a reference angle of 2 pi over 9. Why don't you go ahead and do this next one, and we'll check to see how well you've been tracking what it is that we're talking about here. So I'm just going to go ahead and get this set up. Pause video for a moment and just try number 3. When you feel like you have an answer, unpause, and then you'll check based on what I do. All right, hopefully you are now unpausing the video, having tried number 3. So let's see how you did. 13 pi over 19. Wow, that's crazy, bro. Half of 19 would be 8.5. So 13 being larger than 8.5, but less than 19 tells me that 13 pi over 9 is somewhere in quadrant 2. Right, so I'd say maybe right about there. Right. Now, that terminal ray is not in our desired range for arctangent, right? Arctangent giving us angles that are in quadrants 1 or 4, right? And then this is maybe where reflect was the wrong word, because I don't actually want to reflect this terminal ray. Basically, if I were to reflect this terminal ray into quadrant 1, I wouldn't have the same tangent value as this terminal array, right? It was different for, sine and cosine, where the y coordinate remains the same, negative y coordinate, or the x coordinate remains the same with this negative x coordinate. Here, for the tangent value, we talked about how tangent is like related to the slope of the terminal array. And even outside of that, right, we know that tangent is positive in quadrant one and negative in quadrant two. So it doesn't really make any sense for us to make the claim that these two terminal arrays are going to have the same tangent value. We know that's not true. So really, I guess you could say that you're rotating the terminal array, but what we're looking for is an angle in quadrant four, right? Because that's how we're going to keep our same tangent value, this negative tangent, the same slope for our terminal array, from this 13 pi over 19 to whatever angle measure ends up being here. Right, so we just have to locate the correct quadrant that keeps our same tangent value. But then we will still use the same reference angle. So from 13 to 19 would have been 6. So this reference angle is 6 pi over 19, which means that this reference angle is 6 pi over 19. So between 0 and negative pi over 2 in quadrant 4 with a reference angle of 6 pi over 19, the angle I'm looking for is negative 6 pi over 19. All right. I'm just going to do one more problem. It's going to be slightly different than some problems we've been doing. Still compositions, but yeah, I'll just do number 4 and then we'll sort of close off the video there. So what's going to make problem 4 different is you'll notice in the previous compositions, I gave you sort of like a funky angle, and then you had to evaluate an inverse trig function as sort of your last step of the problem. Versus here, right? The inverse trig comes first with sort of like a atypical, ratio in terms of how you relate to like SOHCAHTOA. And then you're going to evaluate the sine or the cosine or the tangent of whatever this angle would have ended up being. So different in that we're sort of reversing the order in which you're doing the trig versus the inverse trig. But something that remains similar is that the same way that for these problems I said, well, you don't really actually need to know what the sine value is of this angle. You don't need to know what the cosine is of this angle. You don't actually really need to know what the inverse cosine is of this ratio. Like it's not necessary to know what the angle measure is here. Because we've done problems where you didn't actually know anything about the angle measure, but you still evaluated sine, cosine, and tangent. Right? And what do I mean by that? Well, if you remember when we had the setup where you drew the triangles, we used Pythagorean theorem or Pythagorean triples to get the 3 side lengths of the triangle, and then you just did SOHCAHTOA to evaluate sine, cosine, or tangent. It's really all we're going to do here, right? When I look at this first part of the problem, where I see inverse cosine, I'm like, okay, so I'm being quadrants 1 or 2. I can tell that this cosine value is positive, right? This 2/3 would be a cosine value in this setup. So between quadrants 1 and 2, for a positive cosine value, I would know that the angle needs to terminate in quadrant 1. Right? And so then I could draw this triangle where, and this is not going to be a triple, so maybe I just want to go with the adjacent and the hypotenuse here being 2 and 3. But then I could just solve for the y coordinate. So 2 squared plus y squared is equal to 3 squared. And y is going to end up being the square root of 5. Right? But really, I mean, a problem like this is the same as what we were doing back in like day 2 of this unit, just with the, new packaging. They released a new skin for it, I guess. Like this inverse cosine is just telling you, hey, we're restricted to these 2 quadrants, and then you have to read into what the SIGN sign of the cosine ratio is to know, oh, between quadrants 1 and 2, right? For inverse cosine, I wanted quadrant 1 because this cosine is positive. But then just Pythagorean theorem, I got my missing side, and so now I'll just do sine opposite over hypotenuse for this angle measure. So final answer, root 5 over 3. Right? And I never really needed to know what the angle measure was at all. All right. You know what? Why don't we just try number 5? So go ahead and pause the video again, try number 5, and then you can unpause and then check your answer on number 5. All right. So hopefully you just tried number 5 and now you're unpausing the video. I'm just going to go ahead and give you a quick answer for number 5. So 5 over the square root of 29. All right. Hope that went well. I think there should be time remaining in the period. So try out some homework problems. I think we're on IP 06. So do the homework, don't not do it, do it. And if you're viewing this on Monday, I actually will not see you tomorrow. It's regardless of whether I was sick or not. I had a planned absence on the Tuesday anyway. So hopefully Wednesday. Hopefully I see you on Wednesday. All right. Bye, folks.